Our second lesson for this chapter is called data classification. Data classification is a very important lesson for the rest of the class. We have two main objectives. First one is we're going to look at these two keywords, qualitative data and quantitative data. And our second objective is how to classify data with respect to the four levels of measurement: nominal, ordinal, interval, and ratio. So we have four data levels, and we're going to learn how to classify the data with these four levels with this class, with this section. First, two types of data: qualitative data and quantitative data. Qualitative data consists of attributes, labels, or non-numerical entries. For example, one person's measure, or the place that the person was born, his or her eye color. These are some qualitative data because these are non-numerical entries. When we look at quantitative data, the age, weight of a letter, temperature, as you can see, these three things, they involve numbers, and we call them as quantitative data. Now, if you look at this example, the table shows sports-related head injuries treated in US emergency rooms during a recent 5-year span for several sports. Which data are qualitative and which ones are quantitative? So I see that here from basketball, we have this many head injuries. Baseball, we have this many head injuries. And then football, 220,258 injuries. So we have sports column, and then we have head injuries column. So here the sports column is going to represent the qualitative data because these are just attributes. These are the types of sports, and these are non-numerical. But these numbers that we see on the right, they're going to represent the quantitative data. So we have two types of data: qualitative and quantitative data. So these different types of sports, they are non-numerical and they represent the qualitative data. But these numbers on the right column, they're going to show you the quantitative data. So quality and quantity. Now, the second objective of the lesson is the levels of measurement. We have four types of data levels. Nominal data is the first level. It's only the qualitative data, categorized using names, labels, or qualities. You cannot make any math competitions using this level of data. So nominal data is very restricted. It's only the qualitative data. You can categorize it using names, labels, or qualities. The next level data is ordinal level of measurement. So it is still qualitative, or sometimes it is quantitative. So it can be quantitative too, but it can be still ordinal. Data can be arranged in order, or it can be ranked. Differences between data entries is not meaningful. Now, for each data set, determine whether the data set are the nominal level or ordinal level. And we're going to explain our reasoning. So we have the top 5 US occupations with the most job growth. And these job growths are the 5 US occupations: home health and personal care aides, fast food and counter workers, restaurant cooks, software developers and software quality assurance and analysis and testers, and registered nurses. So when I look at them, these are just some of the occupations that I can say, and they do not involve any number. They're all quantitative data, right? So is this nominal data or ordinal level data? Let's talk about this. And then when we look at the movie genres, it can be an action movie, it can be an adventure movie, it can be a comedy movie, drama movie, or horror movie. So these are some movie genres. So far, we talked about the nominal data and ordinal data. So the difference between nominal and ordinal: nominal is very limited. It's always quantitative, but ordinal can be quantitative or qualitative. but it has ranking, right? So when we look at the first part, it has some ranking here. They go from number 1 to number 5. So this set of data is going to represent ordinal level because it has a ranking. But when you look at the second portion here, this is just going to be a nominal data. Let's check our answer. So they said that this group of data, they are ordinal level because they list the rank of 5 largest job growth occupations. And data can be ordered. The difference between rank is not meaningful. So the very first one that they're expecting the most job growth is home health and personal care aides. But when we look at the second portion here, this is a nominal level. This only lists the movie genres, and there is no mathematical combinations here, and you cannot rank this data. So interval level of measurement, quantitative data can be ordered, differences between data entries is meaningful. Zero represents a position on a scale, not an inherent zero. Zero does not imply none. So the third data type is the interval level, and this is always a quantitative data, and that means you can order this data, and this time the differences between these ranking is meaningful, and there's a zero which represents the position on a scale. The last level of data is the ratio level. It's very similar to interval level. Zero entry is an inherent zero, implies none. So if you look at the previous slide, it said that zero represents a position on a scale. It's not an inherent zero. Zero doesn't imply none, but here zero does imply none. A ratio of two data values can be formed. One data value can be expressed as a multiple of another one. We're going to look at an example now. We have two data sets shown here. The first data set is the New York Yankees World Series victories. These are the years that they had the victories. Which data set consists of data at the interval level? Which one consists of data at the ratio level? So these are some years that, as you can see, these are all quantitative data. And you can find the difference between each year. So it is meaningful, right? The difference between 2 days is meaningful. But is there a point taking a ratio between 1927 and 1923? No. So this makes me think that this first data set is going to represent the interval level. When we look at the second data set, it's the 2020 American League home run totals by team. It shows that Baltimore is 77, Boston is 81, Chicago is 96. So this data set here, it shows all quantitative data, and then the difference between the numerical values are meaningful, and the zero means something in this data set, right? And you can take the ratio between these two numbers. So first one is interval level because it's quantitative and you can find the difference between two dates, but the ratio does not make sense. In the second data set, this is called the ratio level. You can find the differences and you can write the ratios between. So for example, here, if the smallest one is, I believe, 59 with Cleveland, and the highest one is New York with 94. So if this one was like 50 and this one was 100, you could say, oh my God, New York almost doubled Cleveland. So this is a ratio level data. Summary of 4 levels of measurements, 4 levels of data: nominal, ordinal, interval, and ratio. So all of these levels, they will put the data in categories. You can arrange the data in order, all of these 3 ones, but except the nominal one, like your eye color or your height, you cannot really order these 2 different attributes. There is no meaning. And then subtract data values. Nominal doesn't allow you to subtract. Ordinal, the difference doesn't make any sense, but the interval and ratio, you can subtract data values. Determine if one data value is a multiple of another one. This is only possible with the highest level, which is called ratio level. Now, if you look at some examples, for nominal level, which is the qualitative data, types of shows, television via network comedy, drama, reality shows, sports documentaries, cooking, soap operas, talk shows. This data set is a nominal data because you can put them in category. A show which was on TV by the network could be put into one of the 8 categories shown. So these ratings like G, PG, PG-13, R, NC-17, this data set represents the ordinal level because it can be qualitative or quantitative. You can put them category and you can put them in order. PG has a stronger restriction than a G rating. And then interval level is the average monthly temperatures for Denver, Colorado, right? These are the average temperatures. You can put them a category, put them in order. You can find the differences between the data entries, but you can't take the ratios, right? And then the last one is the ratio level. This is the average monthly precipitation in Orlando, and these are the numbers. You can put them in a category, put them in order. You can find the difference between data entries, and you can find the ratios of these data entries. There's about twice as much precipitation in June as in March, kind of. This is end of lesson 2 in chapter 1.